Okay, what we're looking at here is the piston, inner piston and outer piston, the two ports that power through the slots in the outer piston, and the inner piston is powered top and bottom with the two side ports, as you'll see the configuration in the 3D drawing that I'm going to do. So you have 4 power strokes per revolution, causing it to be very efficient for steam engines. Okay, here we go on the Dake 3 horsepower square cylinder steam engine, square piston I should say. And this is the inner piston that was referred to in the other video. 4 ports for intake and exhaust, depending on how it's fed. The general outline of it, and then the sides. You can see this port goes down to this hole, and then this end of the piston, if we look here, it goes down inside and comes out this hole, going on around. The port on this side goes to this hole, and the port on this one goes to this side. So we have, designing this, the bottom layer, and because if you see in here where they've gone very deep, had a problem. I had to split the first layer into 2 layers so we didn't get any bleed through from the bushing that they have installed on this on the back side. And there are wear blocks on this on the end. You can see the difference in here. And I'm not going to make those, but I am allowing stock on the machined finished part. And what we noticed was that the center line of the shaft, this circle here and this outer circle, are on 2 different on the same center line, but they're offset 75 thousandths from center. Although these holes are equally spaced on center, 1 inch diameter, 1.125 from center line. And also the distance from this edge to center line and center line to this edge were different by about 60 thousandths. Would have to check that out. But I'm going to show you, I'm going to attempt to 3D print this. And I'm not sure if we're going to have a bushing, brass bushing placed and pinned in this, or if we're going to try and do it completely 3D printed. So I will take you to the computer generation at this point, and we're going to end up and see what we can do. Okay, we're going to start this CAD drawing here and skip the geometry that I had to put in to create the surfaces of everything. We start out with the basic outline drawing of the face that you saw. It left 100 thou stock on the left end, 100 thou stock on the right end, and then the number 2 side corner markings, so we know which direction, and the top and bottom surfaces have 50 thousandths on there for the machining flat and parallel with each other. So let's get started here. We'll turn this off, and the first we had to do was build the first layer. First layer is 150 thousandths thick, and that's basically just what you saw in the other video before it goes into the 4 ports. So the next thing we did to do was add the second layer on top of that. And here's where it got just a little tricky, because now that we've done this, we see that these ports are not round anymore because they had to be made bigger to get away from getting a void in here to bleed through to where the bushing is going to end up. So that's why we did it that way. And that layer is 120 thousandths thick. The next thing we did was we added the port layer, and the port layer has got all the cutouts going in to the different holes each end, and the upper and lower sides of the input. And when we make that solid, we see each, depending on whether it's intake or exhaust, the valving, you have pressure coming in here, and this would push the piston this direction, and then exhausting through this port as it goes around, and you get pressure on the 4 ports as it goes up and down. So the next step was putting the cap on everything, which would be this, and that caps the ports. And the center portion is open. We can either put a bushing in there, or we can try to run it all plastic on the 3D print. And if you add the bushing, that's what it looked like when everything was done. And the bushing is about a 1 inch 130 long. This top layer here is 370 thousandths thick. So now that we've got this assembled, we can take and we can look in the ends and where the ports come in, and you can see the purple portion is the top of each of the ports. And if you look at the bottom portion of it, then it shows us where the ports, so it's all sealed up. And this would show us exactly the pressure, 4 sides for pressure for 4 power strokes per. And looking at it, this circle on the top, the circle on the bottom, are both offset 75 thousandths in this direction. That's the way the other one was. And there was approximately 60 thousandths difference from the left side over here to the right side over here. And you can't see much from the ends looking at it that way. This will give you a nice dimension look. So this is what I've had to do. Okay, what we're going to do now is we're going to take these 5 layers that we've got here and make them into one solid layer. So we can take this first layer, second layer, the third layer, fourth layer, and the fifth layer. And what we can do is we can marry them all into one solid mass. So that's what we've got in here. That's as one solid piece now. No gaps. The lines show up a little bit, but that's okay. It's all one piece. can be 3D printed now. Again, thanks for watching, and we'll let you know how the 3D print comes out.